So for question 7, it asks us, for each of the following, identify a problem, if any, with the set of quantum numbers. So before we can do this, we need to remember the rules for these quantum numbers. And these quantum numbers are like, you know, geographic coordinates of a human being. So if you want to give a geographic coordinates of a human being, you could give latitude, longitude, altitude, and time, right? Because you're right where you are right now, but an hour from now you might be somewhere else, or even 2 minutes from now you might be somewhere else. So that's basically the 4 coordinates that describe things on this planet, right, on Earth. But we could also describe where quantum or where electrons are in terms of their quantum numbers, and those are n, the principal quantum number, L, the angular momentum quantum number, m sub L, the magnetic quantum number, and m sub S, the spin quantum number. And these all have values relative to each other. Now note that these are all possible values of the quantum numbers, but any electron would have specific quantum numbers, exactly 4 quantum numbers specific to that electron, just like you have one specific latitude, longitude, altitude, and time right now. Okay, an electron would have these specific things at a given point in time, and this would be if that electron's there, no other electron could be there, just like no other person could have the exact same 4 coordinates as you could have. All right, so let's look at what these rules are. N is the principal quantum number, 1 to infinity theoretically, and it has to be integers. So n, we talked about in the previous 2 problems, but this is the principal quantum number. All right. Now the values of L. L equals 0 to n minus 1. Again, integers. Another thing to know about L is if L equals 0, we call that an s orbital. If L equals 1, we call it a p orbital. If L equals 2, we call it a d orbital. And if L equals 3, we call it an f orbital, which probably won't come up. Okay, how about m sub L? M sub L equals negative L through 0 to plus L and integers. M sub S is a spin quantum number, which is going to be positive 1/2 or negative 1/2. So these are basically the quantum numbers that are described. So let's take a look here. What is the problem with this? Well, if n equals 1, L could be equal to 0 to n minus 1. Well, 1 minus 1 is 0. So if n equals 1, L has to equal 0. ML could be 0, and MS could always be plus or minus 1/2. So the problem here is n can't be 1. Let's look at the next one. If n equals 3, L equals 1. Is that possible? Yes, because if n equals 3, L could be equal to 0 to n minus 1. 0, 1, or 2. 1 is a possible value. If L equals 1, what are the possible values of ML? Well, ML is negative L through 0 to positive L. So in this case, ML could be equal to negative 1, 0, or 1. It can't be minus 2. So in this case, the problem is ML can't be minus 2. It can only be negative 1, 0, or 1. A p orbital. Remember, there are 3 p orbitals, the negative 1, the 0, and the 1. There's one s orbital, the 0. Okay, so this L of 0 is an s, and there's only one of them. L of 1 is a p, there's 3 of them. Let's look at this one. N equals 3. Since n can be equal to any integer, there can't be a problem really with n. And here we have always plus or minus 1/2, so there can't be really a problem with ms. So L equals 0. Is that possible? Yeah, we just did this. If n equals 1, L could be 0, 1, or 2. 0 to n minus 1. If L equals 0, what are the possible values of m sub L? Well, ML is negative L through positive L, so negative 0 through 0 to positive 0. That doesn't make sense, so it's just 0. That looks okay. And MS is minus 1/2. It could be plus 1/2 or minus 1/2. So here we have no problem with these quantum numbers. Finally, the last one. n equals 1. What could L be? L could equal -1, 0, or 1. It's 0. We're good. What am I doing? Sorry. L could equal 0, 0 to n minus 1. So it could be 0 to 1 minus 1, which is also 0. So L has to be 0. If L is 0, m sub L is -L through 0 to plus L, which is -0 through 0 to positive 0. So mL has to be 0. So here the problem is m sub L can't be minus 1. Has to be equal to 0. Said another way, this is an s orbital, and there's only one s orbital. So I hope this is at least somewhat clear. I know this is a little bit confusing, and this is something you definitely need to watch the lecture about, because going over a problem may be more confusing than less confusing.